Welcome, everyone, to today's presentation of highly available PostgreSQL applications, how to protect from cloud and system outages, brought to you by pgEdge and RT Insights. My name is Katie Bavoso, and I'll be your host. In our event today, we'll be diving into how to make your PostgreSQL applications highly available and more resilient to failures such as cloud outages with real-world use cases and how these companies are achieving high availability. I'm excited to be joined today by pgEdge's own Philip Merrick, co-founder and CEO, and Michael Josephson, solution architect. It's great to be with you both today. Thank you for joining me. Take it away.
Terrific. Thank you so much, Katie. Great to be here. And we're excited to share with the audience here uh, on this topic of how to architect for highly available Postgres applications that can be protected from cloud system outages and other things that literally go bump in the night. Uh, by way of background, as Katie said, I am co-founder and CEO here at pgEdge. Got about a 35-year background in enterprise software, have founded and run a number of successful companies, and most relevant for this audience, that includes EDB. Mike Josephson, is our solutions architect and director of solutions engineering, and you'll be hearing from MJ a little bit later. But first, before we jump into this topic, just a little bit of background on pgEdge. What we do here is we build and market a fully distributed implementation of the highly popular Postgres open source database. And what the solution does is it makes applications, including the new generation of AI applications, simply faster and more reliable. We've got a tremendous background across our team in Postgres. Some have been working with Postgres for as many as 25 plus years, and we're well backed by some fantastic investors, including most recently Akamai Technologies and QBRT, who is actually one of our customers in the financial services industry. Let's take a little bit of a step back and think first about the growing demands on today's enterprise applications. And this applies to AI applications, web applications, mobile applications, anything that's critical to your business. What we know about these applications today is they have to be always on, always available, and they probably have to serve a global user base. And they may even be called upon to operate in a multi-cloud or hybrid cloud environment. And we could be biased, but we think pgEdge Distributed Postgres is an extremely effective way of meeting these demands. So why do we care about high availability? Well, quite simply, it equates to lost revenue and poor customer experiences. Uh, there have been some recent surveys on just how much of a concern this is for practitioners in application development and operations. 83%, according to one recent survey, are concerned about their cloud provider failing in a single region. And in fact, 1 in 5 have already experienced that. A New Relic survey last year told us that across the group that they surveyed, annual downtime from major outages was as much as 77 hours, and each of those hours cost up to $2 million in lost revenue and productivity. We know also that in some industries, it's not just a question of lost revenue, it's a question of the company's credibility, the company's brand, and there are quite simply a lot of applications where the allowed amount of downtime is basically zero. And so that's really what we're getting at when we're talking about high availability. Alongside this, we see Postgres becoming an ever more dominant part of the database landscape. A few stats here. 60% of the top 400 SaaS companies rely on Postgres one way or another. It's actually now something like 65% of the Fortune 500 rely on Postgres in some part of their organization or perhaps broadly across their organization. That includes 17 of the largest financial services companies in the US. The federal government's a very large user of Postgres. However, absent pgEdge, there's no sensible, open, and supported solution for distributed Postgres. And as you'll see over the course of this webinar presentation, distributed Postgres is a critical part of a highly available Postgres application architecture. So what does our fully distributed Postgres product entail? Well, first of all, it's built on multi-master asynchronous logical replication. And when we couple that inbuilt support for asynchronous logical replication that can take writes at multiple nodes on the network with local streaming replication, we have a highly resilient architecture that can deliver close to zero RTO, recovery time objective, or zero RPO, recovery point objective, how much data loss you can tolerate. So with many of our most demanding customers, there's very little tolerance for any downtime or any data loss. And that's where this kind of highly available architecture shines. Our solutions optimize for geographic distribution, specifically in the cloud, multi-region deployments. And that's important if you're considering the dependency on a single cloud provider region, of course. But it's also important as you think about your failover strategy. So the idea of a disaster recovery strategy coupled with failover for high availability means that you're really addressing two problems at once, both high availability and the need for a disaster recovery plan. pgEdge distributed Postgres as part of a suitable application architecture can deliver up to 4 or even 5 nines of high availability. And when we say 4 nines or 5 nines, we mean 99.99% or 99.999% as measured over the course of 1 year. Now, I've been already talking a lot about high availability. That is the topic of today's webinar, but there are multiple use cases for pgEdge distributed Postgres, which I'll just briefly touch on. Low latency is kind of the flip side of the high availability coin. So what we mean by that is, if you think about having remote users across an ocean, then if you've got your database and application stack in just one location on one side of the ocean or the other, then the users on the other side of the ocean are going to experience significant delays as data is retrieved and presented over the link over the ocean. And so low latency, the ability to deliver a consistent user experience regardless of where a user is located, that's actually an added benefit of solving for high availability. pgEdge distributed Postgres, as I touched on earlier, can be used in multi-cloud and hybrid cloud applications. We also are a great replacement for the Oracle Golden Gate product, which provides multi-master replication capabilities in the Oracle environment. And there's a lot of interest in moving from legacy Oracle applications to Postgres, particularly as part of a cloud modernization, cloud transformation project. And then, quite exciting, pgEdge distributed Postgres can be used to provide for what we call AI inference at the edge, or edge AI, where we're able to bring the decisions created by the AI application, the decisions the AI outputs, much closer to the user, which is pretty important if it's some sort of time-critical application. So those are some of the use cases, but we are really focused here on high availability. And in fact, if we look at the use cases across many of our customers, they are coming to us because high availability is a prime requirement for them, and that's the reason why they're interested in pgEdge. And we've worked very successfully with a number of fantastic customers to deploy high availability architectures with some very stringent requirements. This includes QBRT in the investment management industry, Talus in security software, Bertelsmann in Germany, and also several agencies in the US government focused on national security. And with that, I'm going to turn things over to MJ to give you a deeper technical look at pgEdge and also to follow that up with a demo. MJ, over to you.
Thanks so much, Philip. Really looking forward to going through a little bit more of the pgEdge architecture and actually show the platform live. So with that said, let me jump right into it. At the core of our platform is asynchronous multi-master replication. It lets you do write to any node and automatically syncs the data across a network. It's a powerful foundation that gives applications the flexibility to operate from anywhere, with the resilience needed to stay online even in the face of disruption. Additionally, we include configurable conflict resolution and reporting. This gives you granular control over how data conflicts are addressed, a sometimes common issue that can arise given the ability to write to two nodes at the same time at the same location. Furthermore, with this capability, with the capabilities that pgEdge provides, you can do latency-based routing. This allows you to automatically connect to the nearest available node, minimizing the latency and speed to access the data, reducing that burden on the end user as they're in an application or trying to access that data. Time is money. Access to that data is critical. We also provide robust support for high availability. I'm really going to do a deep dive into this over the next couple of slides, so I'm not going to dig too much on it specifically here, but it's a critical part of what pgEdge provides, and there's really unique ways that you can design the infrastructure for it. And finally, we support the distributed vector storage and similarity search. This is a really powerful part of a database that is really now starting to become more prevalent and understood on how this can truly help and support AI applications. So with that said, let me talk a little bit more about that underlying multi-master architecture. So taking a look at it, at the core of our multi-master replication is the ability to handle writing in parallel. This dramatically enhances scalability and ensures high availability, especially for critical, demanding, always-on applications. Of course, writing to multiple nodes introduces the potential of conflicts. That's why we have different ways in which you can handle for conflicts in pgEdge. We have the ability to do, say, a last update wins, be able to do running sums, handle for those particular use cases that are inevitably going to arise with the ability to write to multiple nodes at any given time. This also provides the ability to do some things like our load distribution. The ability to write to multiple different nodes opens up the interesting ways you can distribute your load across the actual cluster itself, right? Writes are no longer specifically needing to be in US East or EU West. You have flexibility of where you can put that, and it provides additional layer of fault tolerance. You're going to find that we have fault tolerance built in at many layers of pgEdge, which is a key power of the platform itself. In addition to that multi-master support, pgEdge also offers physical replication support, which further strengthens the infrastructure, provides the capability to offload read workloads to your replica nodes, enhancing performance, reducing pressure on that primary node, and providing an additional layer of fault tolerance. Again, fault tolerance at the multi-master layer, fault tolerance at the physical replication layer, that is providing those abilities to handle for the circumstances that can potentially happen. Maybe a region goes down. Being able to have a backup for those circumstances optimizes the uptime for your data specifically. Now, when it comes to managing node failure, there's actually a couple ways that you can handle that with pgEdge. pgEdge offers flexible strategies. One approach used by several of our customers is to manage failover directly within the application layer. In this setup, the application can detect and communicate with multiple nodes within your cluster, intelligently choosing where to read from and write from based on the availability of those nodes. Now, that said, if you want a more classical approach, you can, say, offload some of that responsibility to a load balancer, abstracting the database layer entirely from the application. This means your app doesn't need to know anything about the underlying nodes, giving you the freedom to add or remove nodes seamlessly without touching application logic. Each approach has its advantages, and with pgEdge, you're not locked into one or the other. The key is flexibility. One of the things that you're going to see consistently with pgEdge is you have flexibility to meet your business requirements in a variety of different ways. So with that said, what are some of the core constructs that make up pgEdge? Looking at the pgEdge kind of under the covers, there are several core components that work together to deliver robust pgEdge distributed Postgres. At the heart of it all is Spock, our multi-master replication engine. It's responsible for enabling simultaneous writes across nodes and handles the conflicts that inevitably arise during that, ensuring that your data is consistent no matter where it originates. To ensure global uniqueness of records, we use Snowflake sequences. This is an extension to Postgres that we've created. These provide scalable, distributed ID generation that's both easy to implement and more flexible than some of the traditional options out there. We also support large object replication through a feature called Loader. This is an extension as well to Postgres, something that's not available in standard Postgres. We're handling for an edge case that can potentially arise. Then we have ACE, our active consistency engine. It provides an added layer of protection against data drift in distributed environments, ensuring your nodes remain aligned while simplifying ongoing system administration. Finally, we've built in a flexible management layer. Whether you're deploying through the CLI, Ansible, or Kubernetes, we've streamlined the setup process to make launching and managing pgEdge environments fast and straightforward. As for the pgEdge Cloud, our managed service offering, I want to share a bit of context around how we've designed and architected it. At its core, pgEdge Cloud is all about simplifying the deployment, configuration, and ongoing administration of the pgEdge platform, including our robust multi-master replication, conflict resolution, and consistency safeguards. We've built it using best-in-class tooling, ensuring optimized load distribution and enterprise-grade reliability at scale. Most importantly, it's designed to help you meet stringent availability targets while keeping your application and data always on and responsive for end users. pgEdge Cloud follows a bring your own cloud model, which gives you the flexibility to leverage your existing cloud credits and enterprise discounts, integrate seamlessly with your preferred providers, whether that's AWS, Azure, or GCP, and still benefit from automated deployments and streamlined management via the pgEdge Cloud interface. In short, pgEdge Cloud delivers the full power of pgEdge with the speed and flexibility you need without the operational burdens. So with that said, let me jump into a demo of pgEdge. Now in this demo, what I want to do is I want to walk you through a couple key examples of use cases that have come up with some of our customers. And then I actually want to show you a cluster running pgEdge and some of the core capabilities that we have built in. So now, an example that I've seen come up again and again with some of our customers is they have a 2-node cluster that's spread geographically throughout the United States. And in this circumstance, they want the ability to handle for a circumstance where, let's say, US East goes down, as been known to happen every once in a while, or US West. What happens in that circumstance is I can then immediately, based on the strategies that I mentioned before, redirect that individual or that request to my other database. So in effect, I'm able to ensure that my data is available, my application is accessible, and I'm not losing the attention or the purchasing of my end user. Another example here with a slightly more complex configuration, maybe there's a need for data residency requirements, right? You have that flexibility with pgEdge. In this case, let's say for this 3-node cluster, one of my nodes goes down. Again, I'm able to seamlessly redirect that end user to the next closest node. I'm not even affecting this other user here. And in the end, I'm able to do my reads and I'm able to do my writes to those specific users. Again, opens up flexibility for handling for inevitable circumstances that could arise. So now if I were to dig that a layer deeper in, and let's actually jump into a 2-node cluster that I have set up here, right? I have both of these are running locally on my server right here. And what I'm able to do is I'm actually able to see the data in each of them. If I'm able to, let's say I want to add a new snack here, let's say another Doritos Cooler Ranch. And then what will happen here is that's going to be replicated over to my other node. I can also conversely delete this. This is also going to be replicated over, right? Now, let's say I want to potentially take one of these nodes down. So let me go ahead and take down my right node here. Let me just pause real quick. One of the things that I built in, so in this particular circumstance, what I've actually built out is application load balancing. So what I'm doing is I'm connecting directly to both nodes through this application that I have here. Got basically an intermediary layer that basically is querying every so often my database. And once that's been specifically detected, you'll see here that the server status changes to the server is no longer available. That said, because I have a 2-node cluster here, I can still go ahead and update and interact with one of my other one of my other servers, right? So I have that level of flexibility here to particularly handle for that. Now, this node is down, so what I'd like to have happen is the data to then synchronize once that node comes back up, right? So if I pop that node back up, it's going to take a second for it to load here. Let me just pause 1 second. And while that's loading up, just to talk a little bit about what that architecture might look like, right? I have the ability to access my, through say like a load balancer here. It can have say like a global load balancer, which is determining which node group I want it to go to. Maybe it's region based, maybe it's just access based on whether there's a detection of something down or not. And then I also have here that additional layers of flexibility in the case that, say, I have a failure at the node group level. I want to do a promotion for one of the read replicas. You have that flexibility. There's a lot of ways in which you can design and architect for a thoughtful, highly performant, highly available multi-master cluster here. So with that said, as you can see, my node came back up. The data has been synchronized here, so both nodes are back up to date. Again, another way in which pgEdge is able to handle for a circumstance that can arise, right? If you have one node down, you still want functioning, you want the synchronization of that data that happens during the course of, say, once that node is brought back up. Another question that I actually just got today from one of my customers was, well, what happens in the case that it's a split node? Let's say the network connectivity between the two is down. How does pgEdge handle for that particular circumstance? Well, we're actually able to accept writes on both, right? So you can actually handle for a circumstance where maybe you have network isolation because there is a controller that cuts a network cable and causes inaccessibility between the specific nodes, right? Being able to handle for that circumstance allows you to still be able to manage the requests that are coming in. So it's a great, powerful part of the platform is that you're able to handle for these different unique use cases that can come up commonly. So with that said, that was kind of the heart of what I wanted to demonstrate to you all today.
Philip, MJ, thank you both so much for that presentation. Now, I'm sure we get a lot of common questions, so I want to dig into a few to make sure we give our audience everything they need to know. Let's backtrack a little bit and review what a high availability architecture looks like again. We talked about it in the beginning. I'd love to kind of revisit that so our audience really has a picture.
Yeah, thanks so much for bringing that up. That's a common question that we get all the time. And the really great thing about pgEdge is you have a lot of flexibility on it. One of the things I showed during the course of the demo was a 6 node cluster, right? You had two read write nodes, and each of those had two attached read nodes. That's one way in which you can handle for high availability. But the great thing is with the multi-master capabilities, it can really go a variety of different directions. If you want to necessarily have, say, multiple read write nodes, and you want those to be geographically distributed globally, right, to give you that optimal low latency action with relation to the data layer, that's not a problem as well. So you have that level of flexibility to really design an infrastructure to meet your business requirements, your low latency requirements, your high uptime requirements.
Fantastic. Thank you so much for revisiting that and going over those. Let's move on to this next question. How do you avoid, or how do you handle, rather, conflicts?
Another great question, and something we hear all the time. How are we handling for conflicts, right? Ultimately, there's a couple of different ways you can handle for it. For numeric values, maybe based on the criticality of the data, that you may want to do something like a running sum. That's one of the core capabilities that pgEdge provides, right? I have the ability to write to two different nodes at the exact same time. If it's an account balance that I'm updating, I actually want the aggregation of that information. You have that ability with pgEdge. Additionally, you also have the ability to do something like last update wins, a common need for many of our customers. And more than that, we're also releasing very shortly some additional enhancements to provide even greater capabilities based on the feedback of our customers. The feedback of our customers is really critical to us organizationally. We love to hear how people are using it, and we love to adapt our product to ensure we meet their business needs.
Phenomenal. We look forward to seeing updates as we continue. A couple more questions for you before we go out today. What is the difference between high availability and disaster recovery?
Yeah, I can take that one. So these two capabilities, if you architect right, actually go hand in hand. So the idea of high availability is quite simply that the system should be up for measured over a period of time that meets the specified availability requirement, whether that's 99.99%, four nines, or five nines. So that's high availability. It's simply the capability of the system to be up and running, meeting a particular requirement for uptime. Uh, Disaster recovery is a different but related thing where we say, okay, so if the primary site for an application becomes unavailable, typically for some period of time, if you're thinking about disaster recovery, you're thinking about perhaps some natural disaster, maybe some event that's taken out the grid for a period of time, something of that nature. Uh, you need to be able to quickly be up and running in another location. And so, with a high availability architecture that actually runs across multiple regions, across geographically separated data centers, you actually have your disaster recovery strategy effectively built in. So, it comes with that high availability architecture.
Last question today, gentlemen. What about zero downtime maintenance? Is that something pgEdge enables?
Yes, it is. So, regular software updates, regular software maintenance has in the past meant that you have to take the system down, the application offline while that is happening. And of course, if your system has to be up and running almost all the time, that's unacceptable. And we find in some industries, like in financial services, where previously you could use the weekends because you weren't trading over the weekends. You could use the weekends for software maintenance. That's increasingly no longer the case. And so, hence the need to move to zero downtime maintenance. And with a fully distributed database system such as pgEdge, it's possible to do your upgrades on a rolling basis. So you take one node of the cluster down and you perform the software upgrade on that, and then have it rejoin the cluster, and then you take the next node down and do the same thing, and you repeat until you've updated each of the nodes in the cluster. And so that way, the cluster overall can be available for the application, and as far as the user is concerned, there's no interruption. Now, depending on what the capacity of the nodes in the cluster happens to be, maybe there's a bit of a performance hit as you take one node down. But if that's a concern, then you can make sure that you've provisioned enough capacity at each of the nodes so that even when you have one node going down for maintenance, the rest of the cluster can pick up the load without a performance degradation.
Thank you both to Philip and Michael for joining me today. If you have any more questions and you'd like to learn more, you can check out the link on your screen, pgEdge.com/get-started. Once again, I'm Katie Bavoso for pgEdge and RT Insights. Have a great day.